Hey everyone, welcome back. We have a large square, ABCD, and tucked perfectly into its bottom left corner is a smaller blue square, AEPM. Now, we have two crucial pieces of information. First, the top right corner of the small blue square, point P, is exactly at the center of the large square. And second, the area of the small blue square is exactly 2 square units. Now, look at the empty space in the top right corner. There's a green circle sitting there, touching the 2 sides of the large square. Its center is point Q, and our goal is to find the exact area of this green circle. Let's work through it, step by step. First, we need to figure out the dimensions of the squares. The area of the small square is 2. Since the area of a square is side squared, its side squared equals 2. Taking the square root, every side of the small square has length the square root of 2. So, AM is square root of 2, and PM is also square root of 2. Now, let's draw a diagonal from A to P. This splits the small square into a right triangle. The 2 legs are both square root of 2, and the hypotenuse is AP. Using the Pythagorean theorem, square root of 2 squared plus square root of 2 squared equals AP squared. That's 2 plus 2 equals AP squared. So, AP squared equals 4. Taking the positive square root, AP equals 2. And here's where the whole picture starts to make sense. Point P is the exact center of the large square. So let's extend the diagonal from P all the way to the opposite corner, C. Now, A, P, and C all lie on the same diagonal of the large square. Since P is the center, it divides the diagonal into 2 equal pieces. We already know AP is 2. Therefore, PC is also exactly 2 units. Now let's turn our attention to the green circle. Its center is Q. From Q, draw a perpendicular to the top side, BC, and call the point where it touches S. And draw another perpendicular from Q to the right side, CD, and call that point T. Because these are radii drawn to the sides of the circle, QS and QT are both radii. Let's call the radius lowercase r. Since QT equals r, the horizontal distance from C to S is also r, so CS equals r. Now, focus on the tiny right triangle near the top right corner, triangle QCS. Its 2 legs are both r, so we only need to figure out its hypotenuse, QC. And here's the clever part. We know that PC is 2, but Q lies somewhere between P and C. The distance PQ is a radius, so PQ equals r. Therefore, QC equals PC minus PQ. That's 2 minus r. Now we have everything we need. Triangle QCS is a right triangle. So by the Pythagorean theorem, r squared plus r squared equals the quantity 2 minus r squared. Let's expand the right side. We get 2r squared equals 4 minus 4r plus r squared. Move everything to one side, and we get r squared plus 4r minus 4 equals 0. Now, let's solve this quadratic without using the quadratic formula. Complete the square. -4 can be written as 4 minus 8. So our equation becomes r squared plus 4r plus 4 equals 8. And look at the left side. It's a perfect square. The quantity r plus 2, completely squared, equals 8. Take the positive square root, because a radius must be positive. So, r plus 2 equals the square root of 8. And the square root of 8 simplifies to 2 times the square root of 2. Therefore, r equals 2 times the square root of 2 minus 2. Let's factor out a 2. So the radius is 2 times the quantity square root of 2 minus 1. And now the grand finale. We can finally find the area of the green circle. The area of a circle is pi times the radius squared. So area equals pi times the quantity 2 times the square root of 2 minus 1 squared. First, square the 2 outside the parentheses. That gives us 4. Now square the bracketed expression. The quantity square root of 2 minus 1 squared expands to 2 minus 2 times the square root of 2 plus 1. That's 3 minus 2 times the square root of 2. So our final answer is 4 pi multiplied by the quantity 3 minus 2 times the square root of 2 square units. And there we have it. If you enjoyed this geometry challenge, hit that like button, subscribe for more clever math puzzles, and I'll see you in the next one.